Alrighty, long time no talk. How's everyone doing? Can't hear me now, but I want to let all my Algebra 2 students know that starting Wednesday, give me a second. Today's the 3rd, 4th. Let's go April 8th, whatever that Wednesday is. We are going to be doing Zoom lessons. So pay attention to your school email, and I will email everyone the Zoom code. So basically you download the Zoom app and then click on it, and you'll get to basically be in a virtual classroom. I know that sounds like a blast for everyone, but I believe there are some of you out there who, even if you don't miss math, miss learning. So, giving you that opportunity. So, today, this is what I posted on my Google Classroom. Rationalizing denominators. We're going to take a look at what that means. This is something that a lot of people had difficulty with when we went over it in class, and so I figured it'd be a good thing to kind of brush up on. So, here he is. So, remember, when we're talking about rationalizing denominators, what our goal... I forgot my... hold on just a second. My tablet has this neat little stand, so I can set you up right there and talk at it. So, we'll see how that works. Anyway, it's not working very well. Okay, so... when the goal of rationalizing a denominator is to ensure that and I know this is kind of self-explanatory, but I want to go over it anyway, to ensure that the denominator is a rational number. A rational number means any number that can be expressed as a terminating or repeating decimal, okay? So we're looking at here the 4th root of 24. Now remember, when that index pops up, if there's no index number there, I don't see any on this page, but I'm pretty sure we have one later on. When there's no index number there, that index being that 4 right there, it's a 2. Now that there is an index number there, we know that it's the 4, so it's the 4th root of. So what we want to do here is we want to break 24 down. Okay, we want to get 24 into its most basic components. This is called prime factorization. Because what we don't want to do is sit there and make this more complicated than it needs to be, which would basically be multiplying it by the 4th root of 24th to the 3rd power. That would give us 4 24s, and we could take a 24 out. So 24, is 2 times 12. 12 is 2 times 6, and 6 is 2 times 3. So here we've got 3 2s and 1 3. Well, in order to get rid of that, we need 4 of each one, because it's the 4th root. So we need 4 2s, and we need 4 3s. So we want to sit there and ask ourselves, hey, what are we missing? How many 4s are we missing? Or not how many 4s are we missing, how many 2s are we missing? And how many 3s are we missing? So when we look at this, we see that what we're missing is 1 2 and 1 3. So we have 1 2 that we're adding, and 3 3s, because we need 4 of each. Okay? Because that's what the 4th root tells us. So 3 times 3 times 3 is 27. 2 times 27 is 54. So we're multiplying this by the 4th root of 54. And what that gives us is the 4th root of 2 times 2 times 2 times 2 times 3 times 3 times 3 times 3. So up top in the numerator, where we just kind of need to follow the order of operations and see what happens, what we do is we distribute that fourth root of 24. I'm clearly not very good at this anymore. I don't thought I was ever good at it, but I was better at it. So 8 times the fourth root of 54 is 8 fourth roots of 54. Plus, now when we have the fourth root of 2 and the fourth root of 54. So what we can do there is we can multiply those two together and get 108. Now, because we know, I want to quick look down here. Because we know that we got 54 by multiplying 3 3s and a 2, even when we add in one more 2, there's not enough there to kind of pull anything out. Okay? So we can't do anything there. So the fourth root of 108 is basically as simplified as it can get. Now on the bottom, we're going to get the fourth root of 2 times 2 times 2 times 2. So those first 3 2's came from the 24. That last 2 came from the 54. 3 times 3 times 3 times 3. That first 3 came from 24. That group of 3 3's came from the 54. Now notice here, because it's the fourth root, we can take 1 2 out and 1 3 out. So that's 3 times 2 is 6. So we put all of that over 6, and boom. What's going on here? Why did I do 108? Yeah, that's wrong. Ignore that. 16 times 9 is not. Okay, so that's right here. This is your answer. Okay. Not sure where this is all going. Yeah, that's wrong. So the one that okay, so number 2. So here we have the fourth root of 5. So we need 4 5s to get rid of it. Now we already have 1. We already have 1 5. And that's why it's okay to sit there and just go, okay, we're going to add in 3 5s. Because when we're done, that's going to give us... So we have 9 fourth roots of 125 over the fourth root of 625. Well, the fourth root of 625 is 5. So that's our answer. So what we want to do here, we don't want to necessarily always just jump to, we can't just go, oh, it's times the square root of 5, because that only adds 1 5, or times the fourth root of 5. Because that only adds 1 5 in there. What we want to be able to do is make sure that we have those 4 5s. So if we're already having 1 5 there, then by adding in another 3, we end up with 4 5s. And the fourth root of 5 to the fourth is, well, 5. Easy peasy. So next up, we have number 3. Number 3, so we have the fourth root of 100 right there. So because 100 isn't a perfect fourth root, what we want to do is we want to break down... Hold on just a second, I'm kind of in an awkward position. Give me a second. I'm doing this from my bed, so... because there's too much noise out in the living room right now. So I had slipped down kind of more and more, and then I tried to go take a sip of coffee, and it wasn't working out. So anyway, fourth root of 100. What we want to do is we want to break this down, and that's 2 times 50. 50 is 2 times 25. and 25 is 5 times 5. So we have 2 2s and 5 5s. Now remember, we need 4 of each. So we need 2 more 2s and 2 more 5s. So basically, we are halfway there. Okay? So what we need to do is we need to add in another 100. So we're going to multiply it by the 4th root of 100 and the 4th root of 100. And when we do that, so up top, when we sit there and distribute that 4th root of 100, 4th root of 100 times 1 is the 4th root of 100. 4th root of 2 times the 4th root of 100 is the 4th root of 200. Because the indexes are the same, we're capable of just sitting there and multiplying it by itself. Not like the 100 by itself, but the 2 times 100. Then on the bottom, we get 100 times 100, which is 10,000. Now notice here, so we have those 4 2s and those 4 5s, right? So we can take out 1 2 1 5. 2 times 5 is 10. And that's how it goes. And we're back. Okay, so next up, we have this one. Okay, so we have the cubed root of 25. So here again, what we need to add is we need to add enough numbers to where we can get rid of that root in the denominator. So 25 is 5 times 5. So we need to add one more 5. So we're going to go the cubed root of 5 times the cubed root of 5. This gives us 10 cubed roots of 5 plus the cubed root of, I don't know why I put 50. That's 100. Give me a second. 5 times 20, just so you guys know, is not 50, but in fact 100. And then on the bottom, we have 3 5s. Cubed root of 3 5s is 5. So there we go. That's our answer. Okay, guys, make sure you guys know how to do this. The factoring itself is a fairly important part of what we do. And so even being able to factor is crucial. Even if it's not in this specific circumstance, the ability to factor really is key. Okay, so moving on. Next page, we're going to look at 5. So here we have 8 times the cubed root of 8 over the cubed root of 10. So we know 10 is 2 times 5. So what we need to do is we need to add in 2 of each. 2 2s, 2 5s. So to figure out what number we're then going to use, we multiply 2 times 2, 4, times 5, 20, times 5, 100. So what we're going to do is we're going to multiply with the cubed root of 100. So this is going to give us 8 cubed roots of 100 over the cubed root of 1,000. Cubed root of 1,000 is 10. So we have 8 cubed roots of 1,000 over 10. Now here, what we can do is we can actually simplify that because we have 8 times 8 over 10. So we can factor out a 2, get rid of the 2, and that's going to give us 4 cubed roots of 100 over 5. Again, if any of this isn't making sense, 1, feel free to drop me an email. 2, rewatch the problem, rewatch the video. Watch kind of how it breaks down, what it does, blah, 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 blah. Okay. Moving on. So number 6. Again, we have the cubed root of 10 here. So we know that what we need to do is multiply it by the cubed root of 100. right? So we have the same denominator as we did in number 5, so we need to multiply by the same thing. So that's going to give us 5 cubed roots of 100 over 10. 5 over 10 reduces to 1/2, so we have the cubed root of 100 over 2. Hopefully this is starting to make sense. Okay. Next, we have the 4th root of 375. So the 4th root of 375, we're going to pull a 5 out first. Okay? That's going to give us 5 times 75. Use a calculator. They are helpful. 75 is 5 times 15, and 15 is 5 times 3. So what we're looking here for is we want 4 5s and 4 3s. It's the 4th root of something, so in order to get rid of that root, we need to make sure that we have 4 of everything that's underneath there. Okay? So we're going to add in 1 5 and 3 3s. 3 times 3 times 3 is 27. 27 times 5 is 135. So we're going to multiply this by the cubed root of 135 over the cubed root of 135. Just like we've been doing all along, we are now going to distribute. So we end up with negative 9 4th roots of 135 plus the 4th root of 675. And all of that goes over 15. How do I know it's 15? Well, 1, I can use my calculator. And 2, you can also sit there and go, okay, I know I'm pulling out 1 5 and 1 3. 3 times 5 is 15. So I know that 15 to the 4th power has got to be whatever 375 times 135 is. But as always, if you're not feeling comfortable with that, make sure you double check it with a calculator. Your calculator can do all of this stuff for you. Okay, moving on. So 375, if we look at this, we know it breaks down to 5 times 5 times 5 times 3. 135 is 5 times 3 times 3 times 3. So we have 4 3s, 4 5s. 5 times 3 is 15. And 675, we can pull a 5 out. Because we knew that when we added in the 135, actually, yeah, I don't know where that came from. That's just the 4th root of 675. I did not do a very good. See, I needed the math practice too. Put all that over. Nope, that's not over. Put all that over 15. And that's your answer. I don't know why it's being stupid, not letting me circle. Okay. Now quick, go on to the next page before anyone sees what an atrocity that is. Okay, so next we have number 8, which is a negative 8 minus the cubed root of 2 over the cubed root of 100. Now we know that 100 is 10 times 10. So the cubed root, we just need to add one more 10 in. So we distribute up top, cubed root of negative 8, cubed root of 10. And then we go the cubed root of 2 times the cubed root of 10 gives us negative cubed root of 20. All of that is going to go over 10. Nothing to reduce there, so that's our answer. Okay, number 9. So we're going to go 9 is 3 times 3, right? So we know that we need 4 9s to get rid of this. And we already have 2, not 4 9s, we need 4 3s. And we already have 2, so we're just going to go ahead and add 2 more. So 3 times 3 is 9. So we're going to multiply both the top and the bottom by the 4th root of 9. That gives us 4 4th roots of 9 plus the 4th root of 27 over 3. $50 on number 10. 2 times 25. 25 is 5 times 5. So we need 3 of each, which means we need 2 2s and a 5. 4 times 5, 20. So we're going to go over cubed root of 20 over the cubed root of 20. That gives us 2 cubed roots of 20 over the cubed root of 1,000, which turns into, okay, so that's 2 cubed roots of 20 over 10, because we know that the cubed root of 1,000 is 10. We also know that we're pulling out 1, 2, and 1, 5. 2 times 5 is 10. Now notice here we have 2 divided by 10, which is, so if we have 2 over 10, that is going to reduce to 1 over 5, because 2 is 1 times 2, and 10 is 2 times 5. So the 2's cancel out. We're left with 1 over 5. So our final answer there is cubed root of 20 over 5. That's all I got for you guys today. Make sure that you guys know how to do this. And I really hope to see you guys all next Wednesday. Like I said, I believe that's April 8th. And on Zoom, I'll email the Zoom conference code to your personal email. Not your personal email, your school email. And you can either show up and do video or do sound only, but I'd love to see all of you guys. So take care, have a safe and sane and wonderful weekend. I'll see you guys Wednesday at 10 o'clock in the morning.